Hello, sir. How are you?
Good evening, how are you?
I'm good, thank you. Sorry for the delay.
No, it's fine, it's fine.
Okay,
Okay, thank you. Welcome.
thank
Now,
you.
this is my syllabus. I think that to start in, we have done shapes of molecule last week. Have we done shapes of molecule?
Sorry? No, you
Can you
said
see
we were
my
going to.
screen?
I can.
Have we done shapes of molecules?
Yeah, we have. You said you're going to explain when I asked the question about why the bond lines are different. You said that's what we're gonna start by doing in our next class.
Okay. Oh, that's true. Oh my God. Oh my God. But okay. Oh God, oh God, oh God, oh God. Oh God. I didn't remember I said. I remember I said that. That's true. That's true.
Yes.
That's true. It's okay. But we have done it. I just have to show you how it looks like. Am I right? I've done this. Am I right?
Yes, we have done it.
Okay, but I have to show you the practical way of understanding it. Am I right?
Yes.
Okay, I got it. Oh God. I didn't remember that. Didn't make any provision for it. It's okay. It's fine. It's fine. It's okay. Now, for today, are you listening to me, please?
Yes, I am.
Let us do intermolecular first, please.
Okay.
For today, I've done that, but I need to demonstrate that practical aspect for you so that you can understand it very well. Do you get? Now, intermolecular forces is present in all covalent molecules. So we need to get this right first of all. Come and see this. Good. We have talked about electronegativity. Am I right?
Yes.
Ability of an atom to attract electrons to itself. So the point is, pay attention here. Let me just say this that way. Now, a polar bond. What's a polar bond?
A polar bond has permanent dipoles. A polar bond is formed between atoms of elements of different electronegativities.
Thank you. You start with that. Look at it. If you have, I'll take group now. Look at FONClBr. This guy, they are highly electronegative. Then number two, carbon, hydrogen, boron, silicon, aluminium. These are common one. The other one, I just give you the common one. Boron, silicon. They have what? They have low electronegativity. Low electronegativity.
Okay.
Now, when you combine a member from one and any member from one and any member from two, you have a very polar bond. Or let's just say you have a polar bond. A polar bond. When you combine any member of one with any member of two. Example, hydrogen from, like now, example, hydrogen chloride gas. We say hydrogen is positive, chlorine is negative. Water, oxygen is negative, H is positive. Carbon monoxide, O is negative. Do you get the point now? When you take any member of one with any member of two, the bond form is a polar bond, actually very polar bond. Is that okay? That's one. But when you take a member of one and another member of one, a different member of one, for example, in the sensitivity value, they will give you the exam. This guy is about 4.0. You don't have to, they'll give you an exam. This guy is 3.5, 3.0, 3.0, 2.5. Carbon is about 1.1. Hydrogen is about 1.0. Boron is about, I think, 1 point, maybe almost 1.0. Let's say 1.0 again. Silicon is 1.0. Aluminum is maybe 0.9. Now look at the guys on top. They are highly electric. Look at the value attached to them. Look at the guys down. They have no electronegativity. So when you take any member from one and any member from two, join together, such a bond is a polar bond. So a polar bond, like I said it here, look at it here. Oh, what is this? So you can say a polar bond is formed between atoms of different electronegativity. A polar bond is the one that is formed between atoms of different electronegativity. A polar bond will now have partial charge. We call them dipoles. This guy, look at this guy, and this guy is here. This one, this, and this. We call them partial charges or dipoles. Partial charges or dipoles. Is that okay?
Yes.
Because the atoms, so a polar bond is formed between atoms of different electronegativity. That's what a polar bond is. So H2 is polar. Why? Because oxygen is more electronegative than hydrogen. HCl is polar because chlorine is more electronegative than hydrogen. Ammonia is polar because nitrogen is more electronegative than who? And hydrogen carry positive pole, positive pole, positive dipole. This guy negative dipole. With this one, I wrote on body. I mean, that one they are polar. But you now take a member of one. Now look at members of one. They have high electronegativity, but the values are still far apart. When you take a member of one with another member of one, the bond form is still polar, but it's not as polar as, let me call this guy A. The bond formed in A is highly polar. Why? Atoms have very wide difference in their electronegativity. The bond formed in A is highly polar. Is that okay? Bond formed
Yes.
in B now, for example, OF2. OF2 is a compound of oxygen and fluorine. O is very high, but fluorine is higher. This bond is still polar. So in this case, fluorine carries negative. Fluorine carries negative. Oxygen is forced to carry positive. Is that okay? I've done that one. Nitrogen dioxide. Oxygen is stronger than it. Oxygen carries negative. Oxygen negative. Nitrogen positive.
Okay.
I'll do another one. Nitrogen bromide. Nitrogen bromide. Nitrogen is stronger than bromine. Nitrogen carries negative. Bromine is forced to carry positive. Then this compound is chlorine bromide. Chlorine will be negative. Bromine will be positive. But
So I have a
iodine
question.
bromide, hold on please. This guy will not be negative and positive. What's your question? I'm listening.
How do we know that nitrogen is the one that has to be negative and bromine positive, or fluorine negative and
You have
oxygen
to
positive?
remember that lithium, beryllium, let me write on top. You have to remember that lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, sulfur, chlorine, bromine, iodine. It increases this way. We've done that before, and decreases this way. Do you get the point? I have to remember that.
Yes.
So it increases across the period and reaches a maximum value at fluorine. They start decreasing downward. So this element I've written in front of you here now, which of these elements in front of you is the most electronegative? It increases across the period and decreases down the group. Based on those two statements alone, which of these elements in front of you has the highest electronegativity?
Fluorine.
Thank you. Then the next one could either be chlorine or oxygen. Do you agree?
Oh, okay.
Because
Yes.
it increases from oxygen to fluorine,
Mm.
then decreases from fluorine to chlorine. Do you get? So
Yes.
after fluorine, the next one might be maybe oxygen or chlorine. Actually, it is oxygen.
Okay.
Because the rate of increase here is just increasing gradually. This guy is 3.0,
Mm.
3.5, 4.0, 3.5, no, 3.0. So the rate of increase across the period is gradual. The rate of decrease down the group is rapid. Do you get the point now? So from
Mm-hmm.
the value I've written in, I can see now that you agree that fluorine is the most electronegative. Actually, you have to remember this trend. These are the one you likely, they won't ask you outside this one, the exam. Fluorine is the most, followed by oxygen. Then nitrogen and chlorine are similar, then bromine finally. Of course, iodine is
Mm-hmm.
very, very slow. Is that okay?
Yes.
When you pick a member of one and a member of two, the bond form is polar, very polar bond. When you pick now among the members in group one, this
Mm.
one in front of you, these guys still differ in their value. So if you combine fluorine and oxygen, fluorine is stronger than oxygen. So fluorine carries negative, oxygen carries positive. If you
Okay.
combine oxygen and nitrogen, who carries negative? Oxygen. Who carries positive? Nitrogen. What if you combine nitrogen and bromine? Who carries negative? Nitrogen. Who carries positive? Bromine.
Mm.
Do you get the point?
Yes, I do.
Yes, good. But this guy, okay, now, good. So this guy, now look at, let me give you one example. Oxygen, oxygen and chlorine forms a compound. Look at it, oxygen and chlorine. Because oxygen is stronger, it carries negative, chlorine carries positive, positive. But when oxygen and fluorine form similar compound, look at OF2. Oxygen carries positive because fluorine is stronger. But in OCl2, oxygen carries negative because oxygen is stronger. Do you get the point now? The
Yes, I.
stronger guy carries negative, the other one carries positive. Do you get the point now? This
Mm.
compound exists, ICl3, Cl. Cl is stronger, so it carries negative, negative, negative. The chlorine carry positive. Do you get the point now? So
Mm.
all these bonds. So, but the question is this: bond formed in A and bond formed in B. Samuda, which one is a stronger polar bond? They are both polar. Bonds in A are polar. Bonds in A are formed by combining a member of one and a member of two. The
Mm.
bond formed in B is a member of one with
Mm.
another member of one. So bond formed in A and in B, which one is more polar?
A is more polar.
Thank you, because the difference in electronegativity is very wide. So
Yes.
the greater the electronegativity difference, the more polar the bond is. Is that okay? So
Yes.
I'll put it down. The greater the electronegativity difference, the more polar is the bond. The more polar is the bond. So I say number one, A is polar. Now know very polar. B is polar, not very polar, but this one is what? A polar also, polar bond. Am I right?
Mm.
It looks rough, I'm sorry. I will say that you can get it. Number one, A is a very polar bond. B is polar, but not as polar as A. Is that okay? Now let's now
Yes.
go for C, and that's C combination of C.
Mm.
If you combine a member of one, a member of two, is that why I wrote my two? Let me see my two. A member from two and two, if you combine them, a member of two and another member, e.g., carbon and hydrogen, boron and hydrogen, boron and silicon. Is that okay? Then
Yes.
aluminum and what? Boron, all those stuff like that. Because these guys, look at the members of two, their values are very low and they are very close also. Unlike members of one, the values are still far apart. The members of two, the values are very close and very, very close. So this one, when you come, remember, is almost non-polar. This one is what? Almost non-polar. Is that okay?
Mm-hmm.
Do you get that now?
Yes.
Why? The values are close. The values are what? Are very close. Is that okay? Then
Yes.
finally now, D. When you combine the same elements combined, is completely non-polar. Same element combined. Give me an example of same element combined. Chlorine molecule, Cl and Cl. Oxygen molecule, O and O. Nitrogen molecule, N and N. H and H. Br and Br. F and F. This one, completely non-polar. So I've given you 4 types now. Completely what? Non-polar. If they are the same element, of course, the 2 elements have the same electronegativity. The
They'll
bond
cancel.
becomes non-polar. Do you agree? So let's start. Group A and group 1 and 2. Group 1 are highly electronegative. Group 2 are, and the values are still far apart. It's like saying, who is the richest man in the world? Hello?
Sir.
Let's say this is Elon Musk. This is Elon Musk. This is Bill Gates. This is, who should I call that? Dangote in Nigeria. He's a rich man. Though these guys are very rich, but there are some things that most can afford to buy that Gates will not dare to buy it. Do you agree to that?
Yes.
Because Gates is like a centi-billionaire. Maybe the worth of, maybe let's say the worth of this guy is like maybe 680 billion, $680 billion. This guy is like maybe $420. This guy is like maybe, I don't know, maybe $120. So they are very big, they are all billionaire, but they still differ in their strength. Do you get the point now? You understand? So I'm saying that these guys are very high electronegativity, but the values still differ apart. They are about 4.5 apart. But this one that are low, the values are very close. So a member of one with a member of two is a very polar bond. You get it? A member of one with another member of one is polar, but not as polar as the previous one. Do you agree?
Yes.
Then a member of two and another member of two, the bond is almost non-polar. Why? The values are very close. And finally, a member of two elements combined, which will be completely non-polar. Is that okay? So without
Yeah.
understanding, thank you. So these are covalent molecules. Now, when you not talk about intermolecular, so you get it now. We're not talking about intermolecular forces in covalent molecule. So we talk about number one, all covalent molecules, all of them. There are 3 types of intermolecular forces. I will be applying this polar, non-polar, and intermolecular forces. There are 3 types. We have what we call induced dipole, instantaneous dipole, permanent dipole, hydrogen bonding. Let me explain that to you. When you say chlorine and chlorine, this force between them. When you say HBr, no, let me write it together. When you say HBr and HBr, this force between them, this force, all hold them together. When you say H2O and H2O, this thing that hold them together, well, is that okay? I don't know that. So this guy, this one is induced dipole. This one is permanent dipole. This one here is called hydrogen bonding. So intermolecular forces are forces that hold molecules together. So in chlorine molecule, what type of bond hold the 2 chlorine atoms together? In Cl2, what type of bond hold the 2 chlorine atoms together? It is covalent. Do you agree?
Yes.
In HBr also is covalent. Within water, covalent, but between water molecule and another water molecule, we have what we call intermolecular forces, which is called hydrogen bonding. Between HBr and HBr, intermolecular forces, we call it permanent dipole. Then between, so how do we know them? Let's go. So this one is called instantaneous dipoles induce The dipoles, or you can call it temporary dipoles. But this one is what? Permanent dipoles, permanent dipoles. This one is hydrogen bonding. How do we know them? Let's start. Covalent molecules now. How do we know them? Covalent molecules. All covalent molecules have ID. All of them have it. Any covalent molecule, all of them have it. Now, there are two types of covalent molecules. We have non-polar covalent molecules, and we also have what? Polar covalent molecules. The non-polar guy, all they have is ID only. They don't have any other one. They have ID only. This polar guy, in addition to ID, they also have what? PD. Do you get the point now?
A lot, and you're like, okay, do you have a private tuition? Don't you have? Do you have? And yes, Ajiro Tech do have a private tuition. So by my right, you can see that we have for the Edexcel and Cambridge IGCSE, and yes, we do have for all subjects. Okay, all subjects. Okay, the popular ones that's always been in demand is mathematics, English language as a second language. Okay, we have physics, we have biology, we have chemistry, and we have the flagship, which is ICT, just here and there. We also have business studies. So if you're interested for a private tuition, I think all you have to do is send an email to the sales team at ajirotech@gmail.com, and they would reply to you, talk about your time zone, talk about, and the fee is really quite affordable. Really, it's really quite affordable. It's when you look at it across other tutoring service, I think this is the one that's quite affordable, and you get the very best of service. We also have for the E-levels as well, and also for the Edexcel. So we have for the Cambridge E-levels and Edexcel E-levels. Okay, and we have also across the subject mathematics, which is usually the hot cake when it comes to E-level, mathematics and chemistry, and then biology. These are usually one of the ones we have in demand always, all the time. Even physics, for E-level. So all you have to do, if you're watching this right now and you are interested for a private tuition, then you can do yourself a solid, okay, and send an email to the sales team at ajiro@gmail.com, and they'll reply to you. And the good news about this is, what I've discussed with the sales team is, we've tried as much as possible to see how we can subsidize the amount according to countries, so it doesn't really look very, very heavy. Okay, so this is really important. Yes, we do charge in pounds, but again, we try to be as much as possible considerate to your countries, and we don't just skyrocket the price. No, because at the end of the day, we know how it feels, and we really want you to actually get the best of service, and again, be able to afford it from the comfort of your home. So again, Ajiro Tech private tuition is currently ongoing. You can enroll yourself for the IGCSE, and then for the E-levels. Again, for the IGCSEs, these are the subjects, and for the E-levels, these are also the subjects. So again, what are you waiting for? Just send an email to the sales team. If you're an IGCSE student preparing for IGCSE, if you're watching this in 2025, watching this in 2026, watching this in 2027, we're currently ongoing, and this is actually a good time for you to actually explore, and then get it tailored to your own needs. So trust me, you don't want to miss out.
I'll say it again. All covalent molecules have ID. All of them have it. You are covalent. The non-polar molecules, all they have is ID only. They don't have anything other than that. But the polar molecules, they have PD. In addition to ID. Do you get? But there are two types of polar now. There are two types of polar. We have those guys that are polar with no hydrogen bonding. What about this guy? Polar with hydrogen bonding. Polar with no hydrogen bonding. Polar with hydrogen bonding. Polar with no hydrogen bonding. Then polar with what? Hydrogen bonding. So we have, so if I'm to categorize for you now, we only have 3 types of molecules. What are the molecules that are non-polar? Number 1, those that are polar and have no hydrogen bonding. Those which are polar and have hydrogen bonding. And the 3 types of molecules, that's what we have. All covalent molecules belong here, all of them. They are either non-polar and they have ID forces between their molecules only, or they are polar and they don't have hydrogen bonding, or they are polar and they have hydrogen bonding. Is that okay? So let's see them. How do we know non-polar molecules? Now, based on the electronegativity that you have learned now, you understand non-polar molecules now. I'm giving you an example now. How do we know non-polar molecules? Number 1, non-polar molecules. Number 1, non-polar molecules. There are 3 types. Number 1 can be same atom, non-polar. Br2 non-polar, I2 non-polar, H2 non-polar, O2, N2. If they are all the same type of molecule, there should be non-polar overall, O2, O3, O2, O2, O3, P4, P4. Let me save this word. Let me save it. Yeah, document. Yeah, let me save it. Okay, I've saved it. Yeah, O2, O3, P4, S8. If all the atoms are the same type, the molecule will not be polar overall. S8. There is one allotrope of carbon. We call it buckyball, C60. All of these, they are all non-polar molecules. All they have between them. So we are saying that between Cl2 and Cl2, between H2 and H2, they are non-polar. N2 and N2. So what are these? So what are these? This, and this. They are all ID forces. Is that okay? Because all these molecules are non-polar. Is that okay? He's talking about non-polar molecules. Number 2, there are some guys that contain polar bond. That's very important. I'll tell you that. Pay attention here. But overall, they are non-polar. Let me give you an instance. Look at atom. Atom contain charged particles. That's proton and electron. But overall, is an atom charged or neutral? Kamunda, atoms contain charged particles, namely proton and electron. But overall, an atom, is it charged or neutral?
It's neutral.
Thank you. Why is that so? Because total number of positive and negative charge are equal to each other, so they cancel out themselves. Do you agree to that?
Yes.
So somebody can have charged particles, but yet overall neutral. So some molecules they have polar bonds. They overall they are non-polar. Let me give an example of salt. Pay attention. Molecules, so number 2, still on non-polar bond. Molecules which have polar bonds. Molecules which have polar bonds, such but are symmetrical and therefore, but are symmetrical and therefore polarities of the bond cancel, and therefore polarities or dipoles of bonds cancel out. So example now, when you say example, you understand. Now look at it. Carbon dioxide. O is from group 1, C is from group 2. So each of the CO bond is polar because O is more electronegative than carbon. Then O group is carbon. Carbon is group 4. What does it do here? It shares 2 electrons with oxygen, 2 with oxygen again. At the end of the day, Mr. Carbon has no lone pairs left. He has still the 4 electrons. Now, look at it. It's like you have something there. You do this, pull it. O is pulling into itself. O is also pulling into itself. There's a body here. Now, O is pulling it. This guy is 7 newtons, 7 newtons. Kamuda, look at this thing and these forces I drew here up top now. What's the resultant of that force?
0.
Thank you. One is pulling it to the right. The other one is pulling to the right. They are pulling to this with the same strength. So at the end of the day, the polarity of this bond will cancel themselves. So this bond will not be polar over, will not be polar. The molecule will not be polar overall. So CO carbon dioxide contain polar bond. But carbon dioxide molecule is non-polar. Do you get English? Carbon dioxide contain polar bonds. Why? O is more electronegative than carbon. The carbon dioxide as a molecule is non-polar. Why? Because the molecule is symmetrical. Symmetrical means same atom. Let me give you an example so I can understand. Look at it. Beryllium chloride. Beryllium is group 2. It has shared the 2 electrons. Before you can say you are symmetrical, you must have exhausted all your outer shared electrons to form covalent bond. And there must not be any lone pairs on you. Let me show you this in the notes. Let me show you this in the notes. Okay. Yeah, can you read this?
A nonpolar.
No, from here.
The bonds that what? The
The
bonds
bonds
in
in
such a
such a
molecule.
molecule are symmetrically arranged. Electron cloud is evenly distributed, and the partial charges cancel out. Do you get the point now? Now, can you read this again? Read this place again. Read this place.
The molecules consist of polar bonds. The molecules are symmetrical. Polarities of bonds cancel out, and molecules have no overall dipoles.
Do you get English? The each of the bond are polar. So look at them now. Look at CO2. Now, question is CO bond polar? Yes. Polarity here and the polarity here, they are the same. They cancel themselves. What about carbon chlorine? Is polar and polar. They cancel themselves. Polar and polar. They cancel themselves.
Yes.
Look at boron. Boron is a group 3 element. Boron has 3 electrons in the outer shell. Each of these carbon boron bond is very polar, not very polar. It's extremely polar. Each boron fluorine bond, don't forget that fluorine is the most electronegative element. Each of the boron fluorine bond is polar. What happened? It moves. Each of the boron fluorine bond is polar, not just polar. It's extremely polar. What's going on there? Sorry, this thing is moving slowly. Okay, I'm almost there. Okay, yeah, I got it. Each of the boron fluorine bond what's going on? Each of the boron fluorine bond is extremely polar. Don't forget that fluorine is the most electronegative element. But Mr. Boron is a group 3 element. He shares all 3 electrons with fluorine. At the end of the day, Mr. Boron does not have any electron left behind. So this molecule is symmetrical. Look at the next one, SO3. Sulfur is group 6. It shares 2 with O, 2 with O, 2 with O. It cancels out. Look at the next one, tetrachloroethene. This bond, of course, this bond we know is non-polar. It's the same atom. Amara is non-polar. But this one is polar. They cancel out. All the 4 cancel out themselves. Look at this guy again. Bond polar. Carbon is group 4. No electron left. Cancel themselves. Same thing with this guy. Polar. PCl5. Phosphorus is group 5. 1, 2, 3, 4, 5. Nothing for him again. Sulfur is group 6. Can you see now? So all these molecules I wrote here, all these molecules I put here, they all contain polar bonds. But all these molecules are symmetrical. So overall, they are non-polar. There are two conditions for the bond to cancel out themselves. From what I've said so far, what do you think are the two conditions? Before you can know that the bond will cancel, I think I will not be polar overall. Number one, the central atom must not have lone pairs again. The central atom must have used all its electrons to form bond. Do you get the point now? Boron
Yes.
is group 3 bond. Sulfur group 6 bond. Carbon group 4 bond. Silicon group 4 bond. PCl 5, etc., etc. Any trouble here?
No.
Number two, the central atom must be surrounded by the same type of atom. Same type of atom. So this one are in the note already. I don't have to write it here. But look at this guy. Look at this one. Look at this. Now, carbon, hydrogen, chlorine, 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 or chlorine, carbon, chlorine, chlorine, chlorine. This guy is non-polar overall. Do you agree it's non-polar? They cancel themselves. Because carbon is group 4. Each of the chlorine, they are all the same type of atom. They cancel themselves. But this first one is polar. They don't cancel themselves. Before they can cancel themselves, all the atoms surrounding the central atom must be the same type. Must be the same type. Here we have 3 chlorine and 1 hydrogen. They won't cancel themselves. You guys, look at this guy also. Carbon, sulfur, and oxygen is also polar. So it's either both of them are sulfur or both of them are what? Oxygen. It's also polar. But here, this guy is non-polar. This guy is non-polar. Can you see now? These two guys are non-polar. So I'm sure you understand the principle of, before you can say the bond cancel them, so you understand the principle is that the atom in the center should be surrounded by the same type of atom surrounding it. Is that okay? Therefore, the polarity will cancel themselves. So number one, all non-polar molecules, they have what? ID forces only.
Oh, sir.
ID forces, yes?
I'm not understanding there. You're saying covalent molecules are all ID, and then
All
some are...
covalent molecules have ID forces. The non-polar covalent molecule, that's all they have. The polar covalent molecules, in addition to having ID, they also have what? PD.
Oh, they have both.
Thank you. I like that. Polar molecules, in addition to having ID, also have PDP. Let me write it there. PDPD in addition to ID. That means,
okay.
So this guy have PDPD in addition to what?
Okay.
ID.
ID.
Now look at number 2. Look at number 2, molecule 2, polar with hydrogen bonding. Because number 2, does he have ID? Number 2 molecule, the one at number 2 here in front of you, does he have ID?
Number 2, yes, it has.
Does he have PDPD?
Yes.
Does he have hydrogen bonding?
Yeah, polar with no, it doesn't.
How about number 3? Does he have ID?
Yes.
Does he have PDPD?
Yes.
Does he have hydrogen bonding?
Yes.
Now, this is what we'll see. Now, hydrogen bonding is like saying, let's just say 100, let's say $100. Hydrogen is like $100. Now, PDPD is like, let's just say $20. ID, let's just say it's like $5. So for water, for those guys that have hydrogen bonding, we don't emphasize ID. We don't emphasize PD. All we emphasize is hydrogen bonding. Is that okay? So when we are talking about molecule, we emphasize the strongest intermolecular forces present. So if you have hydrogen bonding, we know you have PDPD, we know you have it. We know you also have ID, we know you have all the 3. But our emphasis will be on what? On the hydrogen bonding. Because that's the strongest of them all. Do you get? If you also have ID and PDPD, our emphasis will be on the PDPD that you have, not on the ID. They're supposed to have ID only. Of course, that's the only thing you have. We are going to emphasize that. Is that okay? So they
Yeah.
normally say the strongest intermolecular forces. Now, IDID, other factors being it, is not as strong as PDPD. PDP not as strong as hydrogen bonding. We normally say the strongest in them. So number one, all covalent molecules have IDID. But the non-polar covalent molecules, all they have is IDID. They don't have anything other than that. So when it comes to organic chemistry, all hydrocarbons are non-polar. All hydrocarbons are non-polar. Therefore, the only intermolecular forces present, the only intermolecular forces, IMF, the only intermolecular forces present is what? Are IDID forces. Is that okay?
Yes.
So this guy also HCH is also non-polar. Actually, all hydrocarbons are non-polar. All of them are non-polar, whether saturated or not. Most of them are symmetrical. The polarity of the bond will cancel out themselves. So all hydrocarbons are non-polar. I'm done with that.
A lot, and you're like, okay, do you have a private tuition? Don't you have? Do you have? And yes, Ajiro Tech do have a private tuition. So by my right, you can see that we have for the EdExcel and Cambridge IGCSE, and yes, we do have for all subjects. Okay, all subjects. Okay, the popular ones that's always been in demand is mathematics, English language as a second language. Okay, we have physics, we have biology, we have chemistry, and we have you know the flagship, which is ICT, just here and there. We also have business studies. So if you're interested for a private tuition, I think all you have to do is send an email to the sales team at ajirotech@gmail.com, and they would reply to you, talk about your time zone, talk about, and the fee is really quite affordable. Really, it's really quite affordable. It's when you look at it across other tutoring service, I think this is the one that's quite affordable, and you get the very best of service. We also have for the E levels as well, and also for the EdExcel. So we have for the Cambridge E levels and EdExcel E levels. Okay, and we have also across the subject mathematics, which is usually the hot cake when it comes to E level, mathematics and chemistry, and then biology. These are usually one of the ones we have in demand always, all the time. Even physics, for E level. So all you have to do, if you're watching this right now and you are interested for a private tuition, then you can do yourself a solid, okay, and send an email to the sales team at ajiro@gmail.com, and they'll reply to you. And the good news about this is, what I've discussed with the sales team is, we've tried as much as possible to see how we can subsidize the amount according to countries, so it doesn't really look very, very heavy. Okay, so this is really important. Yes, we do charge in pounds, but again, we try to be as much as possible considerate to your countries, and we don't just skyrocket the price. No, because at the end of the day, we know how it feels, and we really want you to actually get the best of service, and again, be able to afford it from the comfort of your home. So again, Ajiro Tech private tuition is currently ongoing. You can enroll yourself for the IGCSE, and then for the E levels. Again, for the IGCSEs, these are the subjects, and for the E levels, these are also the subjects. So again, what are you waiting for? Just send an email to the sales team. If you're an IGCSE student preparing for IGCSE, if you're watching this in 2025, watching this in 2026, watching this in 2027, we're currently ongoing, and this is actually a good time for you to actually explore, and then get it tailored to your own needs. So trust me, you don't want to You don't want to miss out.
Number two now. What is number two molecule? Polar with no hydrogen bonding. Let's go for that. I think it's here. But I didn't give an example here. Let's go here. Polar with no hydrogen bonding. Please pay attention. Polar with no. No, for you to understand, let me do number three first. That's how to understand it. Polar with hydrogen bonding. You now know those number three first. Polar with what? Hydrogen bonding. For such molecule, they must have H bonded highly to either F, H bonded to O, H bonded to N. For any molecule to have hydrogen bonding, there must be hydrogen in that molecule. The hydrogen atom must be bonded highly to either fluorine or oxygen or nitrogen only, e.g., hydrogen fluoride molecule has hydrogen bonding, water has hydrogen bonding, methanol has hydrogen bonding, hydrogen peroxide has hydrogen bonding, sulfuric acid, which is this, OOOH, it has hydrogen bonding. Are you there?
Yes.
Nitric acid, HNO3, it has hydrogen bonding.
Mm-hmm.
Hydroxylamine, it has hydrogen bonding. Carboxylic acid in organic chemistry, it has hydrogen bonding. Mention all those guys. But let's go for ammonia now. Ammonia has hydrogen bonding. Hydrazine, H2N, NH2 has hydrogen bonding. In organic chemistry, amide has hydrogen bonding. In organic chemistry, amine has hydrogen bonding. Anything that has H bonded to either F or O or N, they all have hydrogen bonding. All of them. Is that okay? They will be bonded to them. So all these guys now. So question one, do water has ID? Yes, water has. Why? Water is covalent. We have said that all covalent have ID. We have said that.
Yes.
So do water has PD? Yes, water is polar. Come and see. For you to have hydrogen bonding, you must have been polar in the first place. Am I right?
Mm-hmm.
That's type of polar. So all polar have PD. Among between the polar now, we now have PD with no hydrogen bonding. We also have PD with hydrogen bonding. So if you have hydrogen bonding, are you polar or not? Yes, you are polar. Before you can have hydrogen bonding, you must have been polar in the first place. Am I right?
Yes.
Good. So can we say all polar molecules have hydrogen bonding? Is that correct or not? All polar molecules have hydrogen bonding. Is that correct?
Yes.
Say, look at what I wrote there. Be careful. All polar molecules have hydrogen bonding.
All polar. No. They don't all have.
Now, I will say it the other way. All hydrogen bonded molecules are polar. Is that correct?
Yes.
Thank
Yes.
you. For you to have hydrogen, we must have been polar in the first place. But not all polar will have hydrogen. Some don't have hydrogen, some have hydrogen bonding. Is that okay? These are the ones that have hydrogen bonding. Is that okay?
Yeah.
So water has hydrogen bonding. Therefore, any molecule that can form hydrogen bonding with water will be very soluble in water. So look at it. Let me show you. This is water molecule. Put the partial charges on them. Positive, negative. Put the lone pairs. I put it. This is water molecule. No, I don't that water molecule. Oxygen, hydrogen. Put the lone pairs. Then put the partial charges. Negative, positive. Now show me the hydrogen bonding you are talking about. This hydrogen bonding. This hydrogen bonding. Is that okay? Hydrogen bonding. You have to read it. There be 3 marks in the exam. 3 marks. You have to draw this 3 marks. Between this is a water molecule and that water molecule. What holds it together is hydrogen bonding. But within water molecule, within the molecule is covalent bond. Between O and H, covalent bond. So let me see this now. Let's see. So tell me this, what's happening here? When I convert ice to water, then water to steam. What's the formula of ice? H2O solid. Formula of water, H2O liquid. Formula of steam, H2O gas. So when you are converting ice to water and water to steam, What type of bonding are you breaking?
Mm.
When you convert ice to water, then water to steam, what type of bond are you breaking?
The hydrogen bond.
Okay, you are breaking hydrogen, that's what you are breaking. You're not breaking, because the formula has not changed. You didn't break any
Mm-hmm.
covalent bond. Water is
Oh.
H2O, ice is H2O, steam is H2O. You have not done anything special. That's why we said that conversion of ice to water, water to steam is a physical change in your ice. It says a physical change. It's not chemical change. You are not forming any new substance. You have only converted them from one state to the other. Is that correct, class?
Mm-hmm.
So my
Yes.
point there is this. So that's everybody. So you can now say, show hydrogen bonding between water and ethanol. Look at this. Look at how I'm showing this now. This is ethanol. I mean methanol. Let's say methanol, and this is water. Show hydrogen bond between two of them. That's what I'll write. I'll do. I don't need the CH3. Oh, it's just that I'll do like this. CH3 OH. Then water. Let me draw water. HOH. That's water molecule. I'll draw another water molecule here. OH. So to show it, hydrogen between water and methanol, put all the lone pairs on oxygen, put the partial charges on all of them, negative and positive, positive and negative, positive, negative, positive, positive. Now, I'll show you the hydrogen bond you are talking about now. We'll show you now. Hydrogen bond is this, the between this O of alcohol and H of water, or between H of alcohol and O of water. That's hydrogen bond. Do you get the point now? In the exam, don't show the two of them, show only one and label it. I'm sure that it could have been. All the matter is that they are electrostatic in nature between what? Opposite, negative and positive pole. Between O of water and H of water. Between O of alcohol and H of water. Or between H of alcohol and O of water. So you are called hydrogen bonding. Is that hydrogen bonding? Is that okay? Hydrogen bonding. Hydrogen is a type of intermolecular force. Is that okay? Just
Mm-hmm.
like I induce dipole, induce dipole. So when molecules have hydrogen bond, what make them do? Hydrogen bonding. Number one, molecules have high boiling point and expected, or high melting point and expected, high melting point and boiling point than what? Than expected. I will show that to you now. Hydrogen sulfide and water. Water is a liquid, that means high boiling point. Hydrogen sulfide is a gas. Despite that the molecular mass of hydrogen sulfide is 34.1, water is ordinary 18. Something that has lower molecular mass has a higher boiling point because it has hydrogen bonding. When there is hydrogen bonding, the gas will have higher boiling point than expected because it takes more energy to break hydrogen bonding than to break
Mm-hmm.
IDID forces. Look at it. H2S, H2S. What do we have here? IDID forces. Are you there? Look at the
Mm-hmm.
second one. H2O, H2O. What do we have here? No, let me space a little. What do we have? H2O, H2O. What do we have here? Stronger. Can you see that stronger forces in the person is stronger? Do you agree? So at the end of
Mm-hmm.
the day, Mr. Water is a liquid, Mr. H2S is a gas. If they ask you why is H2S a gas? Why water is a liquid despite H2S has higher molecular mass? It's simple. Mr. Water has hydrogen bonding. H2S has IDID forces. And hydrogen bonding in water is stronger than IDID forces in H2S. Therefore, it takes more heat energy to break the intermolecular forces in water than in H2S. I will say that again. Why is
Mm-hmm.
water in liquid whereas H2S is a gas? Well, just number one, water has hydrogen bonding, H2S has IDID forces. That's point one. My point two is that I will not say hydrogen bonding is stronger than IDID forces. That's point two. Point three will not be, therefore, it takes more energy to break the what? To break the hydrogen bonding in water than IDID forces in H2S. Do you understand that?
Yeah, so molecular mass doesn't affect.
If in this context, hydrogen bonding takes precedence over molecular mass. But if they
Okay.
all have the same type of molecular masses, come back here. When I talk to ID, I should have mentioned that. Look at the ID forces. Let's say you have this now. Look at this. They are all non-polar. Fluorine has 18. Fluorine, chlorine, bromine, iodine. All these guys, they all have ID force. They don't have any other thing. They are all non-polar, right? So
Mm-hmm.
in this case, molecular mass will count. Do you get the point? They all
Mm-hmm.
have the same type of intermolecular forces. They all
Mm-hmm.
have ID forces. Therefore, the higher the molecular mass, the higher the boiling point. We normally say among these guys, this way, number of electron increases, strength of ID forces increases, boiling points increase. Can you see now?
Yeah.
If they all have the same time, then the molecular mass will count. But in this case, not the same time. H2S has ID only, nothing more. Water
Mm-hmm.
has ID, it has PDPD, just as hydrogen bonding. They will normally emphasize the strongest one. So Mr. Water has hydrogen bonding, which is stronger than ID forces in what? In H2S. Is that okay? If I look at
Mm-hmm.
this again, look at this guy. SFC is a gas. SFC is a, come and say SFC. Come and see it. I will remind you, I will just do it for you today. Okay, it's here, it's in the notes. Look at SFCs. It's among those guys that have polar bond, but overall they are non-polar. Therefore, Mr. SFCs only has what? ID forces only. Do you get the point?
Yeah.
Good. So we are saying that between SFCs molecule, we are saying that SFCs, look at it, we are saying that SFCs, what hold them together is so weak. Look at the now.
Mm-hmm.
What is that? ID forces. But between H2S and SFCs, because SFCs has higher molecular mass than H2S, SFCs contains more electrons than H2S. Therefore, the ID forces in SFCs will be than that of H2S. You agree to that?
That will be, pardon?
This guy has more electrons, stronger ID forces,
Mm-hmm.
therefore higher boiling point than who? Than H2S. You get to is lower.
Okay.
H2S, all it has is ID. SFCs, all it has is ID. When we are comparing ID with each other, the more the number of electrons found in the molecule, the stronger the ID forces, the higher the boiling point. Do you get the point?
Okay.
These two guys, they both have ID only. No other thing is present. Do you get the point? So
Mm.
the more electrons you have, the stronger your ID forces. And Tamuda,
Yes, sir.
were you? I talked to what do you call Mr. Ajiro this evening that I have to be somewhere by 7. But what I will do for you, the 30 minutes I miss, I can give you 1 hour to replace 30 minutes.
You
Do you
can.
understand?
Yes, that's fine.
So all you need to do is that I will talk to Mr. Ajiro, I'll look at my time. The 30 minutes I missed today, I can give 1 hour to replace it. So let's say
Uh,
on Friday, that we can do like 2.5 hours on Friday, just to give you 30 minutes. I can give 1 hour to replace. I make it convenient for you. Something came up. I have to be somewhere by somewhere every Wednesday. I don't know. You just see in my own program. I've been thinking of
mhm.
changing the whole thing yesterday. I tried to think it. I called the person in charge, help me out, and said, no, I have to be there. And there's
Okay.
no time to do that.
It's
Yeah, okay.
okay.
So maybe we'll be doing 1 hour today from next week, 2 hours on Friday. How do you find that?
Oh, okay. Yeah, that's fine.
That Friday, if you have a chance, I can make it 2.5 hours for you. I need to, remember, we need more time for this lab. We need more time. You're not coming.
Mm.
So that we're almost done with topic 3. Now, after topic 3, the other topics are small topics. You just be jumping over. And I have notes for all of them. Because I need to, if you read some of the ahead of me and you get me faster. But this topic 3 is very important. We cannot do it just crossing over it. Do you get the point?
Okay.
So we talked
Yes.
about that. So these guys, don't so that we don't miss stuff. This guy from here, these guys,
Mm-hmm.
Okay, no. Yeah, I was giving an example here that compare these two. I give the reason. Is that okay? Then again,
Mm,
compare these two also. This second pair, they have the same type of intermolecular forces, which is ID, nothing more. If they have the same ID, then the higher the number of electrons present in them, or the higher the molecular mass, then the higher will be the boiling point. Simple. Do you get the point?
yes.
Good. I'm sure that makes sense. So that's
Yeah.
about what hydrogen bonding. Now, about group three now. Group two, rather, we have polar molecules with no hydrogen bonding. Polar molecules with no, it's already seven. I believe another thing to tell me now. Example, now look at this. CH3Cl is polar, but doesn't have CH3COH. There's no OH bonded, so it's polar. It doesn't have hydrogen bonding. Ester in your organic chemistry, is polar. It doesn't have hydrogen bonding. Then
Mm,
CH3F. There's no H and M connected here. Is that okay?
yes.
CO, SO2. Is that okay? Etc. Like then maybe maybe COCl. Is that okay? Then
Yes.
COHH. They are all polar, but they don't have hydrogen bonding because there is no connection between O and H in all these molecules. There is no connection between O and H or H and F. So why is CH, if I ask you, why is CH3Cl, why is it polar? Because chlorine is more electronegative than carbon.
Mm-hmm.
The next guy, why is it polar? Oxygen is more electronegative than carbon, right? The next one,
Yes.
why is it polar? The oxygen atoms are more electronegative than carbon. The next one, why is it polar? Oh, fluorine is more electronegative than carbon. This guy is actually this guy is actually CFHH. So there is no direct bonding between F and H. So they cannot have hydrogen bonding. We only have hydrogen bonding in molecules where we have H directly bonded to F, to N, and to O. They get nothing more. Any other than that, it doesn't have hydrogen bonding. So all these molecules here,
Okay.
they are all polar, but they don't have hydrogen bonding. They are all polar. Do you agree?
Mm,
But they don't have
yes.
hydrogen bonding. Why? There is no direct bonding between H and O, between H and F, or H and N. Do you get the point now? All the
Yes.
molecules are polar, but they don't have hydrogen bonding. Do you get the point now?
Yes.
So this guy, what do they have? They have ID. Do you agree? They also
Mm-hmm.
have what? PDPD. But whereby hydrogen bonding, they don't have. They don't have.
Mm-hmm.
They have ID. They have PDPD, but they don't have hydrogen bonding. But water, this guy said, this guy, water here, does he have ID? That's right, he does. Does he have PDPD? PDPD, yes.
Mm-hmm.
Does he have hydrogen bonding?
Yes.
Yes. So 1 year they said, I'll give you that voice, said, state the strongest intermolecular forces present in the following, present each of the, in each of the words, in each of the following. Number one, CH3OCH3. Number two, CH3CH2CH2CH3. Number three, CH3CH2COOH. Number four, CH3 into 3, then CCl. What that means is CH3, that means CH3. Number four. Then number five, SO3. Number six, That's CH3, CH2, CONH2. So you have to say the strongest intermolecular forces. Then then this guy PbCl4. Lead is a group 4 element. Don't forget that. I agree with you. Lead is what group 4. So I've given you a clue on that so that you know what. So you can practice this as one, then post on the classroom. I can mark it for you. Is that okay? So we are done
Okay.
with intermolecular forces now. We are done with them. So all I need to do for you is this now. I have some questions that I've solved on this.
Mm-hmm.
It's scattered on my system. I will gather them together and post it for you so that you can go over there. Do you get the
Okay.
point? So
Yes.
the next one I'm taking you is state of matter.